Hello, algebra students. So remember this. Oh, good, I can point in the right direction. Remember this back from like at the beginning of the school year, in which Ms. Roach and I were showing you all the different cool realms of algebra that exist. So we are now ending our stats unit and going into a unit that is specifically called equations and their graphs. So as you can imagine, I wanted to come back to this just to have like a big picture overview of what we're really talking about. In the top there, the red, the symbols, equations, numbers, operations, things like that. We've been dealing with a lot of that stuff, and we still will be. But now we're especially going to be focused in on the purple one as well, pictures. So graphs, diagrams, charts, less so on the art thing, maybe when you get to geometry. And but where we're actually looking at not only the equation world of these things, but also what it looks like in different ways to graph them. So this is pretty important stuff. A lot of people really struggle going back and forth between equation world and graph and chart world. So stick with me, and we will make sure that this next section is a breeze and an utter delight. Okay, so this first video is actually going to be a little shorter because it's just kind of an intro section to the unit we're starting. Get out your textbooks, boop, 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 and I want you to turn to page 265. That is the start of our new unit of equations and their graphs. I'm going to just point out a couple of things here, but other than that, I really want you to be the one steering the ship for this first section.
All right, so let's look at the first one. These are the questions that I'm really going to want you to dive into. The first one says, okay, it gives you this table with x and y, and then it puts the exact same thing there. It just writes it as a point, x comma y. You may recall we use the term ordered pair for that. So first of all, using this equation, x plus y equals 5, it wants you to find out, okay, if x is this, and then what would y be, and what would it look like as an actual ordered pair. So let's see, if x is 2, we need to find a number that will add to 2 to give us 5. Well, 3. 2 plus 3 is 5. So right there in my own paper, I'm going to write a 3, and then this point would be parentheses 2 comma 3 end parentheses, and shabam, we're done. That's all we need to do. Then, so that's part A, complete the table, do this whole chunk. Then, and you'll notice you may need some negatives in there, you may need some fractions in there, everything's good. So then in terms of graphing this, that's where stuff definitely gets fun. As usual, we're going to have a coordinate plane, and let me just remind you what this is going to look like. So remember that our first point was 1 comma 4. So I am going to set up my coordinate plane. Honestly, I'm just kind of guessing right now as to exactly how big this needs to be. But if I'm going to do 1 comma 4, this will be my x, this will be my y, and 1 comma 4, I'm going to start at the origin, 0, 0, and then go over 1 on the x-axis and up 4 on the y-axis. There's our first point. Then the next point, you may recall, was 2 comma 3. So I'm going to go over to 2 on the x-axis and 3 on the y-axis, and there we go. The next point, I'm just going to tell you now, this is a spoiler, they give us an x value of -3. So I need to think about that. Let's see, -3 plus what equals 5? Well, it's going to have to get over the 0 and the x and y-axis there, so I'm going to say 8. I think -3 plus +8 is going to give us that. So let's see, -3... and then y would be 8, dooba-dooba-dooba-dooba-doop. There we go. So when you end up graphing all of these, it ends up giving you something that looks a little something, something like that. Shabam. Let's come back to the book for a second and see what they're asking us then. Okay, so it says then, what shape is the graph? Well, I don't know about you, but I'd say that looks like a line. In fact, it looks like a line that has been slightly smudged now. And so that's legit all they're looking for. A couple vocab terms I want to highlight for you later on. Or vocab terms as well as just ways they're phrasing things. So in the next one that has you do a vertical line, so you need to remind yourself, what does vertical mean? I always get that confused, vertical and horizontal. I'm not going to tell you. Try and figure it out. If you need to Google, do it up. Then, let's see, list at least 6 points that are on your line. Well, for a point to be on a line, it has to be like this one, or this one. That's bothering me, I need to fix it. Or something like that. Those points are on the line. A point that is not on the line would be over here, or down here, or in the middle there, or something like that. Those are certainly perfectly good points, but they are not on the line. Okay, so that's what they mean by on and off. Then, number 3 is where things get fun. And so for this one, I'm actually going to take a picture of this and then show you how we can do this on the computer in just a second using a wonderful website called Desmos, since I would imagine that a lot of you do not have a graphing calculator at home. And we'll just have some fun with that. So, let's pause for a second, and I'm going to open up the other camera to show you this on the computer.
And I'm back. So take a look at here. This was number 3. The graph of the equation y equals x squared minus 3x plus 2 follows. There it is. It's parabola. And it says for part A, use a graphing calculator to generate this graph. I want you to go to a website called desmos.com, DESMOS.com, and I will show you exactly what that looks like in a second. So when you go to Desmos, you're going to want to click Start Graphing. Makes sense. And here we are. So I recall that the equation was y equals, I'm now writing it over here, x squared. To do x squared, press Shift and then 6, because that gives you a little caret that looks like that, and that is a good way to get up in the exponent. So I'm going to say x squared, like that, and then do one arrow to the right, like that. Bloop. And then the cursor gets big again. So x squared minus 3x plus 2. There we are. That is the exact graph that was in the textbook. So then let's say, so there's an example of that. And if you wanted to, so now we've figured out how to use this, great. Then it says, what values of x make y equal to 0 in this equation? Well, y is equal to 0 on the x-axis. So I guess to answer that question, you would need to ask yourself, where is y equal to 0? What x values will give us a y equal to 0? I will leave that up to you. Then it says, apply the transformation x comma y, but we're going to move it to x plus 5 comma y. To each point on the graph of this, sketch the resulting graph. What is the equation of the new graph? Well, it says x plus 5, right? So wherever we have an x, we're going to replace it with x plus 5. In fact, let's put that x plus 5 in parentheses. So I'm going to say a new expression, just like that. I'm going to say y equals parentheses x plus 5 caret squared minus 3 parentheses x plus 5 plus 2. And there we are. So it said x plus 5, and when we ended up doing that, voop, it ended up switching it 5 to the left. That's crazy. You would think x plus 5 would send it 5 to the right, and yet it sent it 5 to the left. But there we go. If you're looking at that equation and going, what is happening right now? Don't worry about it. This is just getting our feet wet. You don't have to be completely used to the pool yet.
All right, next let's look at 4 and 5. So those are both actually rather similar, but they both use the word satisfy in them, and that makes me kind of wonder, what on earth do they mean by that? Do they mean like give the equation a nice cold Gatorade after a long run? No, let's find out what satisfy means. So first of all, I'm going to take this equation that they give us, 2x plus 3y equals 12, and then it says find 5 points that satisfy the equation. Well, I'm going to write this, 2x plus 3y equals 12. And since they have given us no specific direction as to what those points need to be, I'm going to pick it. I'm going to say, okay, let's have one of the points be 0. Our x values, rather, is going to be 0. So let's see. 2 times 0 plus 3y equals 12. Well, let's see. What is 2 times 0? Nothing. It goes away. That's why I picked it. And then we have 3y equals 12. We're looking to solve for 3. So right now it's 3 times y. So the opposite of times is divide. Shabam, shabam. And y equals 4. There we go. We now have 0, 4 as one of our points for this. Great. Okay, I'm going to go ahead and erase this now, except for my 0, 4, and let's try another one. So, let's see. Bloop, 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 bloop. Terrific. So, now this time, I'm going to say, how about, I don't know, 1. 1 comma something. So, in this case, it'll be 2 times 1 plus 3y equals 12. Well, this time our x, of course, didn't go away, so it'll be 2 plus 3y equals 12. And again, we're looking to solve for that y, because we want to know what is our y value going to be. So, minus 2, shabam, shabam, 3y equals 12 minus 2 is 10. Then 3y equals 10, so we're going to divide both sides by 3. And this time, it ends up giving us a fraction, 10 over 3. Now, yes, we could rewrite this as 3 1/3, but let's just keep it as an improper fraction. You know me, I like to be improper. And so, I'm going to write this 10 over 3 there like that. It didn't say no fractions, it just said give us the numbers that satisfy the equation. These are 2 of them that satisfy the equation. Then, you'll note that the next part, part B, says find 5 points that do not satisfy the equation. This is actually even easier. My suggestion would be, well, let's start with our 0, 4. Since 0, 4 works, 0, comma, I don't know, 0 sure wouldn't. Since 1, comma, 10 over 3 works, 1, comma, 10 by itself does not. There you go. So these are 2 good ones, these are 2 bad ones, which they're looking for in part B, and you're good to go. You just need to find 3 more for each of these things, and you'll be in great shape. Then for number 5, you're actually doing the exact same thing. Sketch a graph of all of the xy coordinates that satisfy the equation, blah, 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 blah. And then it says, what shape is the graph? Well, for this one, yes, they're using the word satisfy again, but let's actually go back to Desmos. I'm not going to show you how to do it to plug this in, but I will tell you one thing that's going to be really important. So I'm going to come back over to my whiteboard. I have thoroughly erased all of the work that was there. And now it's going to be y minus x squared equals negative 1. Great. So they want y minus x squared to be negative 1. So let's see. Let's just solve this for y equals. Just in general, that is what we've seen a lot with our y equals mx plus b. It's what we're the most familiar with. So I'm going to take this x squared and send it to the other side, like that. Zoop! Right now it's minus x squared. Saying plus x squared is going to make that cancel out. And then we'll have y equals, and let's see. We have now a positive x squared minus 1. Can we combine those? No! No, of course we can't. This x squared has an x term in it, and it's a squared x term. This does not have it in it. We cannot combine those, so we just put them next to each other. X squared minus 1. This is what you are going to want to plug into Desmos. So again, remember Desmos.com is a great way for you to graph these and see what it looks like. Because then it says what shape is the graph, and you can check it out by looking at Desmos.
All right, so here's your homework. I want you to finish all of these problems that I started for you, so that's 1 through 5. And then when you turn the page, the second chunk is very similar, just a little bit harder, and I want you to try 6 through 13. Any questions that you may have, you can put on Google Classroom, and I would be happy to answer, but go ahead and give those a shot. Take a picture of your work when you're done, and you can email that to me. Should I make a Google Classroom assignment for this? Yeah, let's do that. I'm going to make a Google Classroom assignment for this so that you can actually just take a picture and upload those there so that I can take a look at it and give you any helpful suggestions. Tomorrow, then, we're going to move on to section 3.12, which is equations as point testers. Can't wait. Have a good one.